Hello, this is Chef Coding. Today I am starting a new tutorial series about Erlang, and I will try to cover all basics of this programming language. So let's start with fast preview. What is Erlang? Erlang is functional programming language which was created in 1980s so it's pretty old language, but still being used in many fields of our industry, mainly in telecommunications, but also in other fields where high reliability and scaling are crucial factors. So I think it's still worth to learn Erlang. That's why I am recording this tutorial. So to download Erlang, we need to move to official site and move to download website, and here is Windows installer, and also if you are using Macintosh or Linux OS, then here are commands to type in your terminal. If you are using Mac or Linux, then there is not much work to do. After executing these commands, you are ready to use Erlang. Sadly, if you are using Windows, then there is a bit more to do, and I can't show you step by step how to make it to work, but there are many resources in the network where we can find guides which will help you if you are having some issues. After you downloaded Erlang, now you can move to your terminal, and to run Erlang shell you can type ERL. And now we are in Erlang shell, where we can input and execute Erlang expressions. Let's start with the easy one, 1 plus 3, and at the end of each expression in Erlang we need to put dot. This is syntax and it is what it is, and we got 4 as we expected. Obviously we can add and do other arithmetic operations on floats and integers, like subtracting, multiplying and dividing, and we got float. Interesting feature in Erlang is that as programmer you can input number in many different numeral systems. We can achieve that by putting base of this system next hash sign and the number in this system, which base we specify here before hash sign. So for me it's 2, so I just write some binary number. 1 plus 4, 5 plus 16, so I will get 21, and that's correct. Okay, so I think that's all for now about floats and integers. Now we can move to variables. To start talking about variables in Erlang, we need to specify their naming. Every variable name in Erlang has to start with uppercase character, and after that we can freely mix lowercase characters, uppercase characters, digits and underscore. To make example, let's create variable with name var and bound it to value 4. Now when we call name of our variable, we will get value 4 as expected. Nothing new here. But when we try to bounce our variable to new value, let's say 21, the exception error has been raised. It is because in Erlang, like in any other functional programming language, variables are immutable, which means we can't bound new value to variable which is already bounded. Also, when we input some equation like this, our variable name var, which is assigned to value 4, equals sign and the actual for value, we won't get any error. It is because equals sign in Erlang is much more than assigning operator. It is pattern matching operator, and it pattern matches the left side of the equation to the right side. On the right side of our equation, we always have to put the value or variable which is already bounded to some value. It comes to the same thing. On the right side of the equation, there always has to be some value, and on the left side of our equation, we have to put the same value or unbounded variable. When it is same value, then there is no problem. It's true. In mathematic way, it's the valid expression. But this is the same line we were trying to do here. The 6th and 3rd line are the same thing. And it looks even dumb a bit. It has to end up with exception error. So this is when we put values on the left and right side, we have to make sure that these values are the same. But if you put unbounded variable on the left side, we can put whatever value on the right side we want. This value on the right side will be bounded to the variable on the left side. As you can see, now when we call this variable name, we will get the value which was bounded to it. Interesting thing which I like to mention is that thanks to that variables are immutable, we can create really huge integers, because there is not restriction of how much memory it will consume to write our integer. So we can really go wide here. As you can see, I am multiplying pretty big integers here, and I will get the actual result of this multiplication. And we can go even wider. There is actually no limits if it comes about integers here. And I think I can show you that unbounded variables can be bounded to any values we like. And that's all, I think, for now about variables. We'll for sure come back to it. But now let's talk about atoms. Atoms are actually a special data type in Erlang. And these are values which are equal only to themselves, to itself. Let me show you some atom. This is valid atom. And atom, because its value can be stored in some variable. Let's call it var atom. And because it is value, it is now bounded to variable var atom. And please don't misunderstood it. It's not a string. It's not list of characters. Its strings are written in double quotes in Erlang. Let's try to put equal sign between atom and atom2. No match of right hand side value atom2. Pattern matching has failed because we are trying to pattern match two different values. Atom and atom2 is totally different things. I didn't mention how to create atoms. Atoms always start with lowercase letter, so it can be any lowercase letter, and after that we can freely mix uppercase letters, lowercase letters, digits, and underscore too. Mainly when it comes to professional coding, atoms are using only lowercase letters, so hello is a valid atom. Hello is equal only, and the only one equal thing to it is hello. See, there is no error because we are pattern matching same values. Also, there is one other way of creating atoms. We are using to it one quotes, and here we can type whatever we want. Really, we can use even white spaces. We can put new line or digits, special characters, whatever we want. It's valid atom2, but it's not really a common thing. Mainly single quotes atoms are used to create uppercase atoms, like something like this. It is common atom. So atom is new data type, which I think actually exists only in Erlang programming language. I didn't came across any other language where would be something even similar to atoms. It's a pretty weird concept, so take your time. There is no way it will be clarified after first example. We will be using atoms in our tutorial a lot of times, so take your time, and I hope it will clarify in your head. As I said, atoms can be bounded to unbounded variables because they are valid values which are only equals to themselves. It is what is needed to remember. We can bound two different variables. For, let's say, v1 equal week. Week is atom, v1 is unbounded variable. Now we can bound some other unbounded variable to, let's say, week also. And we can try to see if it's the same. v1 equals v2. Yes, it is. It has value week. You can see that after I'm doing any equals expression, the value which is on the right side is always appears on the output, and it is because in Erlang every expression every expression is returning some value, and pattern matching expression is not is not different. That means from each thing returns some value in Erlang, and it is important to remember too. And I think it's all for today. We get to know 3 data types in Erlang. 2 are totally normal, like integers and floating point numbers. But there is one new, I think, for some of you, atoms, which are totally new concept for many of you, I believe. And yes, they are valid values. Same, no less value than integer or float. Also, we had we know how to create a variable, how to bound it to some value. We also know that equal sign is not assigning operator, but pattern matching operator. And that's all what you should remember from this episode. Thank you for watching, and see you soon.